an empty location in space. Game objects come to life by having components added to them.
Okay.
And that includes a whole variety of different components, and your own custom components as well. You can develop mesh renderers, sprite renderers. If you want to do audio in your scene, that's also a component, an audio source component. Your camera comes to life by being a component. Everything is from components. This is actually a guy from something that we're working on here called the Reaper Wraith. This complex 3D object, if you look at him here on the inspector, he's got an animator, a capsule collider, a rigid body. He's got some scripts on there, things for navigation. So everything comes to life through these components. So let's look at what a game object is, what some components on it are, and hopefully that'll kind of fit together a little bit more here.
Okay.
Let's go back to Unity. And I'm going to create a new scene here, because remember, we can have many, many scenes in our project.
Like you said before, scenes are the equivalent of levels.
Scenes are the equivalent of levels. Some folks actually have multiple levels built into one scene.
Right.
You can do that. I typically break them apart by one scene equals one level.
Yes.
My title screen will be one scene. Level 1 is a scene. Level 2 is a scene.
Yep.
Typically named like that too. So here I'm back to an empty scene. On the game object menu, I'm going to create an empty one. So I have an empty game object. Notice right here these properties. On my inspector, I have a name, a tag, which is just some text to assign to the object. And you might be saying, Adam, why would I assign text to an object?
Yeah, why would I? It sounds like I'm overcomplicating things right now.
Because typically in Unity, when you ask the system to find another object,
Yes.
maybe you're a zombie looking for the main player. You typically don't ask for an object by name. You can. You can say gameObject.find and give it a name of an object.
Sounds like it might be kind of expensive if I have a lot of things in my scene.
It's expensive, and some scenes have thousands of objects.
Yeah.
So searching by, and also game names can change. So if you're trying to do gameObject.find on a name, if you have a cloned zombie, maybe you're creating at runtime multiple instances, his name is no longer zombie. It's zombie parenthesis clone.
So it sounds like they're like doing that and incrementing numbers perhaps as well.
So you don't want to do it by name.
Right.
Unless you know that the name won't change.
Yep.
So the other thing is here, using a tag. You can add your own tags. Unity gives you a few built-in ones. If I want to add my own, I say it's an array, so I have to kind of size it out here. This could be zombie. Or maybe I want to find my gravestone, as we might be doing, not strong, gravestone, as we might be doing later on today. When I go back to that game object, or any game object, I now can see that that's there.
Okay.
So game object, we have name, tag, a layer, and a transform. Transform is basically the most important property inside of Unity. This
I would agree.
Where your position is. So notice as I'm moving this guy around, my position's updating. The rotation of this and its scale. Now these equate to these buttons on the toolbar here. So this is position. This little widget here, I'm moving my position by that icon. And notice I can click on the center here and move it around, approximating 3D space, because I'm working in 2D space, but it's approximating 3D space.
Yeah.
Or I can do it by direction, by clicking on the arrow tip. And this is what I do 99% of the time. I use the arrow tips to kind of just really gently place my objects where I want them here.
Yeah.
This one here is rotate, and now it turns into, we get these spherical lines here that we can click on a line and rotate a game object.
Okay.
And then this last one is scale, if we want to scale it out. So if I create, let's go back and create a cube, which is a game object.
Looks like you can scale on each axis as well.
There we go like that, scale it out there, or I can just then scale it. Now, caution, scaling at runtime can be an expensive operation. Sometimes you need to do it, but typically you want to make sure your assets are scaled coming into this.
Okay.
All right, so now our components here are what brings us to life. This is an empty game object. Notice we have these properties right here. Every other component will have, every other game object will have these same game object properties, plus a bunch of components added to it here. So my camera has a camera component, a GUI layer, audio listener, flare layer. My cube has a box collider. We'll talk about that in very, very shortly.
It's like you're adding more functionality here as we're going
Adding
along.
more functionality. If you're a developer, if you ever heard of the decorator pattern where things kind of add on.
Yes.
Similar, although this is kind of a visual aspect of it. If I want to add codons here, we'll look at that very shortly. We're going to use these components as well too. So then again, save early, save often. Control S or File, Save Scene. So we want to call this, after I get my caps lock off, level 1. Okay. Next, let's talk about prefabs and packages. This is how we reuse things inside of Unity.
Absolutely.
In the Unity interface, we can have we can create our zombie.
Okay.
If we want that zombie to go outside of our game and we want to use it in multiple levels, we have to create it in some redistributable way.
Right.
We might have downloaded it from the asset store. In that case, it's already in a distributable package.
Okay.
But we're going to show you how to create those right now.
Okay.
Ready?
So reuse is essentially what we're trying to sell here.
Reuse. Prefabs allow reuse across your scenes.
Okay.
Also within your scene. So you might have that zombie you want to duplicate a bunch of times within your scene. The advantage of using a prefab is if you update that root prefab, everything else that was formed from that prefab gets updated.
Perfect. So make a change to perhaps its speed or its health size.
Yep.
Affect all.
As long as you click that prefab object, everything else gets updated.
Perfect.
And now Unity packages is a separate concept. That's actually a .unity package file as opposed to a .prefab file. When you download something from the asset store, it actually gets cached on your system locally in a folder as a .unity package file. You can click on them. I have a whole folder of them that I use for reuse on my project. You double click on them and it imports into Unity.
Sounds like it's going to save you a lot of time.
Tons of time, tons of time. So let's look at a quick demo of prefabs and packages.
Perfect.
Let's open this old city again here.
Okay.
Because this would be a good example of how you'll find some content gets distributed to you. Let me zoom back here a little bit more.
Yeah.
So if I look in the destroyed city, here's a prefab folder. And if I click on this, notice it says something.prefab here. I click on that prefab, drag it into my scene. So I can now reuse it. Let's just say on this building, maybe I want the sound of wind coming from just this building, or all my buildings, some audio source. I can add an audio source here.
Right.
Now, I added it here, not to my prefab down here. I added it in my scene. So there's two ways this workflow can go. If I look at my scene's prefab right now, it doesn't show my audio component.
Right.
So I can actually push from my scene back down to this guy, which in turn will update all of my other buildings here.
Okay.
So if I click on another building, there's no audio component. If I click on this building, it's right there. So let me click on apply. It's now pushing it down here, and it should have pushed it back out to every other one that stems from it.
As long as your character gets closer to these buildings, you can start to hear the sound effect and noise coming out of it.
Yep. So now as I click all these other buildings, notice there's an audio source on them.
Yeah, you must have 20 or 30 buildings in there, so it
Lots
sounds like
of
it saved you a
buildings.
lot of time.
Absolutely. Especially when you realize you made a mistake and you need to correct it. So let's create really a simple one so you can see. We'll do a new scene. Don't save that. I'm going to create, let's do a cube and an empty game object. Let's duplicate that cube a couple times. Move this guy over. We've got two cubes. I'm going to rename this game object to awesome, can't type today, awesome cubes.
Okay, so game object is the default name for any of these.
Game object is the default name. You got it. So I can take these cubes and I can do one thing called parent them, so I can drag them in here.
Okay.
They become a child of that. Now that means that anytime that I basically move this parent object, the children follow. You see them both there kind of following with it. Mm-hmm. Now I say these are the best cubes of all time. I want to reuse these all over the place. So
very fine color.
very, very fine cubes. So if I take these cubes and I click on them, notice they're white or kind of this grayish color. We'll call it white text. If I click on them and drag them down, let me create a folder here called prefabs, just so we can be a little more organized. Create folder, prefabs. Go into that folder, and now let's take this guy right here from my hierarchy and just simply drag it down. I'm going to drag it down here, drop it. Notice this color turns blue. That's telling you this is a prefab. This has a shared instance somewhere. AwesomeCubes.prefab. Now I can drag this AwesomeCubes.prefab all over my scene.
Yeah. Looks like they even took a little snapshot for you, too.
If I, kind of see these little guys here. If I expand that, I can see this children that they contain. Maybe on one of those cubes, I want to add, just like we did before, an audio source. So I added just an audio source to this guy here. Not in my scene yet, but look what's already happened. You see these little speaker icons?
Yeah.
All of them now have that audio source on them. Audio source.
So it looks like you have the option of editing all of the prefabs, or if you want just one at a time.
Yep, absolutely. Now, if I want just this one here to have, I don't know, audio chords, let's actually do a rigid body, because we'll be looking at that next. If I do a rigid body on this one, because I did it in my scene here, it's not going to apply to anything else, which is exactly what I want. I just want this one to have it, nothing else. So the rest of them don't have them, just this one. If I want the rest of them to have them, click on apply, it gets pushed down to this guy, and then back into my scene, so all the rest of them should now have the rigid body component, and they do.
Looks good.
Very, very easy. All right. So architecture on Unity is something that I think everybody needs to understand, how this fits together. Inside of Unity, we have a couple major components. We have the editor. We have MonoDevelop, which is the built-in code editor. It's a cross-platform code editor. It's not made by Unity. It's another third-party company.
Yes.
And that's used. You can actually download that and play with that as a whole separate product. And it has a game engine built into it. In the editors we saw, we can test right inside of there. You can extend it through scripts. It's a very powerful way of developing your game. The project structure, we look at the folder on disk very briefly. In there we have the assets. That's always a top-level folder you see in Unity.
Okay.
Everything you bring in your project goes in there or a subfolder thereof.
Seems simple enough.
Yep. Now, all the other folders, library, project settings, and temp, that's for stuff that Unity does. If you don't know exactly what's in there, don't mess with it.
Right, probably best to leave it alone.
I list there on the screen if you're interested in knowing what Unity does with that, but it is best to leave them alone.
Okay.
Compilation. Well, we're running code, so something has to get compiled.
Right.
We're doing objects who can have code on them, so behind the scenes, something happens. Mono is always used in Unity to compile your scripts. Now, compilation in Unity might be different than your final build.
Okay.
So Unity is using Mono. Maybe if you're going to Windows Store, your final compilation will be actually .NET.
Right.
So just know that Mono is what's used to compile the scripts. Unity licensed a version of Mono, and so that's what they maintain and use for the editor.
Okay.
You export a Visual Studio project, like I said, for something like Windows Store, that could be generated by .NET. If you're doing a desktop build, it could be generated by Mono. So there's different ways that can be used inside of Unity.
Okay.
Compilation varies per platform.
Yes.
Multiple levels of compilation. In the editor, mono, as I mentioned.
Seems simple enough.
When you then export your project from Unity, as Jason will show you guys later on today, how to bring your game to the Windows, those game assemblies are then generated by it's either Mono or .NET, varying cases.
Okay.
Then in turn, let's say you compile your Visual Studio project, or if it's a Windows standalone build, Unity will actually compile that for you. And that's generated then by potentially another one. So there's different passes that happen here.
Okay.
Sometimes it's important to understand which, because there are different API. Windows Store supports a different API than, say, desktop build.
So it sounds like some pretty low-level stuff, but do you think it's worth very beginners to spend time on this, or is this kind of wants to get further down the road, maybe investigate some time?
It's good to spend time on when you do your first build, because that's typically when you're going to get bit by it. So speaking of build and compiling everything in code, let's talk about code.
Okay.
Game loops are per game object. So in Unity, you have this concept, and actually in game development, of a game loop. That's where everything happens. The C# that's supported, since we're going to talk about C# today in Unity, supports pretty much most of all the major constructs you'd be used to in developing with C#.
Okay.
You can do link, lambdas, anonymous methods, events, etc. Do you have to code? Some folks watching today might not be coders.
Right.
I definitely recommend. I think it's great for everybody to learn code, but not everybody codes. You don't have to. There are other third-party plugins for the Asset Store. Playmaker, Behave, Rain AI is a free one.
Yep.
So Playmaker and Behave are paid products. And they're kind of visual scripting trees, so you don't have to code to be able to use them.
Right, and I think it's one of the big selling points for Unity itself is that it's not as intimidating to a lot of developers out there because it's so appealing to artists and designers as a whole.
Yes, absolutely. Unity has two physics engines that they use. One, they've licensed the physics engine from NVIDIA, which is used by a bunch of companies. So is it any good? Well, Unreal's using it, Unity's using it, Gamebryo Vision, etc. There's a whole bunch of folks using it.
That's right.
And a lot of folks today may have heard of Box 2D. I know we've all heard of it going into before we even knew about what was going on with Unity, actually. And that is used for the 2D engine inside of Unity, and a bunch of other companies are using that as well. And 2D physics are typically faster than 3D because you are...
One less plane to calculate.
One less plane to calculate, you got it. All right, so let's look real quick at coding, physics, and particles. And actually, as we go to Unity here, I do realize there was one quick thing that I left out last time.
Okay.
I mentioned I would also talk about exporting packages. You've created your prefab. You realize this is awesome. You want to reuse it or sell it or give it to someone else. You just simply right-click and export package.
Okay.
There you go. This will export package into a .unity package file. We'll put it on my desktop where everything goes. Call awesome.
And now people can use this in their other projects as well.
Now you can use it in your other projects. You can just double click on it. It will import right in your project.
Perfect.
Of course, I already have it in this project, so we don't see anything. For this code demo, we're going to let's do, we've got all sorts of cool options here. We're going to do this guy here. So code in Unity. Let's create a new scene again.
Okay.
We'll call that level 2 for the last one.
Simple enough. I like it.
We're going to create another cube. It's a really easy base primitive to work with. If I want to create code in here, I like to create a new folder, and I call that folder scripts.
I do the same thing.
You don't have to. You can drop it like I did here.
But it's good to stay organized.
Good to stay organized. Right-click, create, JavaScript, C#, boo. Let's go ahead and create C#. We'll call this my debug demo.
Okay. I always like that you can see the code itself on the right-hand side, too. Very appealing. This way you can quickly glance at what you're doing.
Now, we could use monodevelop here, but since we have made Unity VS for free, I've installed it on the system. That shows right here. You have to import it into every project. So Visual Studio Tools.
It's a package like anything else.
Import it in. It's going to create a folder down there. Unity VS, we're good to go. Double-click on this guy.
Yep.
Now, this code, as of right now, is not going to be doing anything. What we're going to do, Unity gives us two methods. Start, for when this particular object, whatever this code is assigned to when it initializes, debug.log starting.
Okay.
And over here, we've got something called update. This runs every single frame. So that how often is that? Depends on how fast your game is running. It could be 60 frames a second, 230, just all depends. This changes all the time.
Absolutely.
And what we're going to do here, since I mentioned that transform is probably the most important property,
right,
we can just reference it from whatever this code is assigned to.
Okay.
You'll notice this inherits from mono behavior, and that basically allows you to integrate with these game objects. So let's use this code. Right now, it's not being used at all.
And you can see right away it's updated on the imported object on the right-hand side.
You got it. As soon as I switch back to Unity, it detects a code change, does a background compilation with mono.
Yes.
So I'm going to drag this script onto my cube. As soon as I do that, I can see it's just another component here.
Perfect.
This tells me this code is going to be run on this object. I click on play. I can see it moving.
Yeah.
Every frame it's actually being called. And let's go to my console, which is kind of like your debug output window, and I can see starting. Got called once there.
Okay. So we know that function was executed, that start function.
And so this little guy here, transform.translate, this is saying we want to move our transform. And we could actually do, if we look transform.position, we can see our .x, our .y, our .z. And that represents where we are in the world. We saw that as we move an object around, it updates these. So when I say transform.position.x, it's giving me that. Transform.position.y is giving me that. Every single frame here, I'm coming over here and just simply saying, I want you to move forward. This is a predefined vector, it's called. We'll talk about vectors a little bit in our 3D. And this is saying, hey, every frame, we're just going to advance this by a little bit in the forward direction. Forward, in this case, is wherever the object is currently pointing. So if I come in and I rotate this object here, notice it's forward. There is a world forward, which is always the same direction.
Yes.
This is the local forward. And that's why we actually use this translate call. We're saying, hey, go to whatever's forward for this current object.
Okay.
It's forward as opposed to our world forward. So we have several different coordinate systems here. We have our world space, and we have our local space.
Yes.
And we can say move forward in world space or move forward in local space, which is what we're telling it right here.
But relevant to that actual character or object.
Debug.log updating.
Log is your friend because it'll constantly keep you informed of what's going on behind the scenes for your project.
And let's do this. Set a breakpoint. I'm going to say attach to Unity. Build. Go back over to Unity. Give it 1 second here. It's doing this background attach. Wait for it. Are you waiting for it?
I'm waiting. I am very patient. There we go. Looking for Unity. We found it.
Connect to Unity. And it looks like at this point in time, it's having a problem connecting. Of course, the demo gremlins came down from the cameras right into my system. That's OK. So what we will do here is we will. Everybody's seen this before?
That's our task manager, so we can see how our machine is utilizing different parts of our project or our assets at once.
So I closed Unity out. It happens on occasion. It's I would call it more rare, but always save your work, save early, save often.
Actually, we'll have an entire course on this very shortly in the agenda.
Absolutely. So what I want to just show you was how we had attached code to any kind of game object. We can just literally take it, drag it on up, and that code runs for it.
Yes.
Second last thing we'll talk about real quick, physics.
Okay.
We're going to go into this more depth in our 3D course, and then we'll cover particles. So physics, real easy to show. We'll take a game object here. Actually, I think we added a rigid body here. So our game object, we did a cube. On that cube, we added a rigid body component. What is a rigid body? If anybody remembers from high school physics, this is what's giving your object mass.
Okay.
And it's allowing it to understand gravity by default.
Okay.
If I click on play right now, this guy's falling.
Look at them go. All of them.
All of them. They all have that because I added that to that prefab before. Now, they don't understand collisions yet. So if we want to add a collider onto there, it's actually a box. The collider's already on our cube. But we can add colliders. And I think Carl's going to cover that in 2D next. And I'm definitely going to cover colliders when we go over the next session.
We don't want to get ahead of ourselves.
And lastly here, let's go ahead and create a particle system. Just like that, notice these are coming out like wireframes because I have my mode there to textured wire.
Ah, there we go.
Look at that. Just like that, we've got a particle system coming out. I can say my start size. Maybe I want more smoky effect, make them bigger.
Yeah, look at all the variables it exposes to you and how easy that is.
50. There we go. We want smoke, you got smoke. You want small particles like that, perfect. You can apply so many different parameters here.
Rotation, speed, color over time.
You got it. I mean, you can do so many things in there. What people do with the particle effects, amazing.
Yes.
There's a great tutorial on Unity site, like an explosion. One particle effect creates a ring, another one creates an explosion effect out of it, so you can overlap the two of them together and do some really, really neat effects.
It's really part of juicing or increasing the quality of your game, having something as simple as that.
Absolutely. That brings us to the end of this fine session. We talked about intro to Unity, the architecture on there, how we can just simply add code onto it. Now, granted, our code example was pretty simple to hear. We don't want to start out too strong with the code on there.
One step at a time.
One step at a time. Carl's going to cover it more. I'm going to cover it more. So we're going to definitely look at these concepts a little bit more in depth as we get into actual game development as we go on.
Okay.
Talked about game objects. Everything in your scene is basically a game object.
Yep.
Near everything.
The asset store.
Asset store, components, because components are what brings your game objects to life. And are you excited for what's coming next?
Absolutely. We've got 2 more days of this. Today, tomorrow, and I believe on Thursday, we will have other guests in here.
Yes. Now, I want to mention that this module is currently being recorded, and it will be available in about 2-3 weeks on Virtual Academy if you want to rewatch it then as well, which I highly recommend.
Absolutely.
The entire course, everything you see here today and tomorrow. Thank you very much.
Hello, and welcome to the next session. In this section, we will cover how to make a 2D game. We're very excited about that. How we can actually use artwork from the asset store and create a game in less than 40 minutes.
So right here is Carl Carthwaite, who's the head of Unity Evangelist, and I'm Tobiah Marks, who's the Game Evangelist at Microsoft. Why don't you tell us about yourself, Carl?
I've been working a long time in the game industry. I'm very excited about that because I used to work on AAA titles, and then later on I went to work on indie titles. And there I found my passion, and from there actually I joined Unity to share the knowledge of our community, through our community and for our community, and share the knowledge of our devs to our community too. So very exciting. In the last years we've seen a tremendous growth on a lot of indie games, and I keep playing them, keep buying a lot of games thanks to the community.
I'm all about indie games as well. When I graduated college, I started my own game development company making mobile games, and I was able to run that for 4+ years or so until I joined Microsoft as a game evangelist, where I get to talk to game developers like you guys out there and help them out and do cool stuff like that. And I'm based in Mountain View, California. You can find my blog right there if you want to find information. So what are we going to cover today?
Today we're going to cover how to make a 2D game. I can show you actually my screen here. It's a simple game where we press the play button here in Unity, as Adam talked about. And what we see is here we see the game. We can start the game and then start to play the game. When we pick up objects and jump. And what we're going to do is we have to avoid also some objects here. If I don't can avoid it, I die and I get my points. I can play again. So we're going to create how to create here a menu, how to create a character, the animations. Okay. So I'm going to open here the scene next that I have here. This is the scene. Let me go to here. So this is the character. Okay. And what
this is a 2D scene too, so the settings are all set up for 2D.
So you can see here the button 2D. Okay. And I can click on that, and I see now the scene actually in 3D. But I can go to 2D here. Okay. And what we're going to have to do is first we're going to have to create this environment. Okay. Like one of those building blocks. I have here a prefab. Okay. Another prefab here. And move this around. Like we're going to create those building blocks. Okay. And what we're going to do is we're going to have to make an endless runner. See the character running. So we're going to have to move them, move those objects forward. When my character moves one of the components here, we're going to move that forward. Yeah. What we also have to do is actually create our character here, place it in the scene, and make the different animations for it, and also define when we're going to run, jump, and fall
between those animations.
Exactly. And then the cool is the game aspect we're going to create is picking up those objects. Like here we have a fuel can. Okay, here you can see, maximize my screen a little bit. So you have the fuel can here. We're going to have to pick up that fuel can, and we're going to get points for that.
And that's actually going to involve some scripting too.
That we're going to have to create scripting for. Right? The basic will be really focusing the beginning for the artists, like how to bring in the artwork, place it there. And then we're going to have to do the scripting of the character moving, the character picking up, but also playing the audio file, and then avoiding the dangerous part. I have here let me show you here the lasers. And where we have lasers, so we're going to have to avoid those objects and jump over. Otherwise, our character game over. Exactly.
All right, sounds great. Where do we start?
We're going to start with the artwork. So what I'm going to do is I don't want to start with a whole project here finished. I like to start with a total empty project so that you can see everything from begin. So you don't have to. You can start from the beginning, really scratch empty plate, and we're going to start with that. So you don't have to know something really from the beginning. So what we're going to do is a new scene, a new project actually. Okay. We can give it a name here. We're going to give it here 2D game. Okay, and we're going to start with that.
Yeah, remember to make sure the setting's set for 2D.
Oh yes, this is a very good point to point out here. We have here the setting 2D or 3D. The 3D and 2D, it doesn't mean you're going to make a 3D game or a 2D game. It's all about just make it easy and fast. When you're going to make a 2D game, it's the import settings. Okay, so to show
you can change those after you make your project. So if you make it the wrong way, it can be done. But for the defaults, we want to make sure everything's set to 2D.
Yeah. So what I'm going to do, I'm going to put it wrong. And I will show you how you can change it.
Just to show where those settings are?
Yes, exactly. So we're going to create a project. And we don't have to save this project. Okay. And we're restarting Unity. So we have an empty project. Okay. And what we see
looks like it's 3D at the start because we did the wrong setting.
Yeah. Oh, sorry, I clicked the wrong shortcut here. So what we see is here, it says here 2D, but it's actually a toggle button. Very good to point that out. So when you click on the 2D, we see nicely here the screen now in 2D.
And that's just changing the way we're viewing the scene in the editor. It's not actually changing the project settings when we hit that.
Exactly. You can combine 2D and 3D in one project.
So where do we change the import settings?
Very good. So we can go here to edit, and in the project settings, the editor. This is how our editor behaves. Okay. There we can say, instead of a 3D mode, we can say when we import textures or images, put it 2D. Okay. But I can first show you the differences so that you really can understand what the benefit of that is. Okay. You're going to go here, and I have here all images that I have for my game ready.
All the ones we just saw in the previous project?
Yeah. All those images will be available on the Asset Store, totally for free to use. Okay. So I'm going to go here maybe to one of my environment objects, and there you can see I'm going to take here one, and I drag and drop that into Unity in the Assets folder. That's how we import an object. Okay. You see it here? If I want to drag and drop that now in my 2D scene here, it doesn't work.
That's because it's a texture.
Exactly. This is a texture here. I can think of the texture here. So in order to bring a texture into my scene, I have to actually create a 3D object. And I actually like a quad or something, a plane. Okay. F to zoom in, I frame on this object here. Okay. And what we're going to take that texture and drag it on top of there. Okay.
But that's what you would